Hello and welcome once again to episode 95 of Code Completion. We're a group of iOS developers and educators hoping to share what we love most about development, Apple technology, and completing your code. My name is Dimitri and I'll be your host once again for this episode, and I'm joined today by my fellow completionist, Spencer.
Hey there.
So as people get more and more used to SwiftUI, we thought it would be a good time to go over how views and layout work in UIKit, since SwiftUI uses UIKit under the hood. And that's just a reality that you just have to get used to.
Yeah, it's I don't know. We're approaching this interesting point where people are probably going to be learning SwiftUI first as opposed to UIKit, and so, like Dimitri said, maybe they're missing a little bit of knowledge that would help them in SwiftUI itself, or just I feel like history is repeating itself where we tell our students, hey, if you're working on an app that's more than, at that time, like 4 or 5 years old, you're going to be using Objective-C. But now it's, if you're using an app that's more than a couple of years old, it's probably going to have some UIKit in it, right? So having that knowledge of kind of what came before the current hotness is definitely a good idea, I think, even if it's just a little bit, just enough to be dangerous, I suppose.
Mm-hmm. And I have a few older apps that Lynn and I were thinking, oh, maybe we can resurrect these. And the first thing I thought of was you'll need to get comfortable with UIKit since you've been doing a lot of SwiftUI lately if you want to even understand what's going on in these code bases. And then I realized it's also all in Objective-C. So it's probably gonna need a complete rewrite at this point. Especially when some of the projects were written in iOS 3 days. And that's some crusty code there that needs some rethinking for the most part. So yeah, that's what we can hope to kind of go over the general mental model of UIKit today. And what better place to start there than CoreAnimation, because at the end of the day, UIKit is fundamentally dependent on CoreAnimation for almost everything. UIKit provides a user interface kit on top of CoreAnimation. And perhaps if we refer to CoreAnimation's beta name, which was LayerKit, it would make more sense why this is. And that's because CoreAnimation has a robust rendering engine that has a concept of a layer, and these layers can be basically placed on top of each other, embedded into one another, and everything kind of comes out of that as a base mental model.
Yeah, to be honest, I think that's even where my own experience is a little bit lacking, because the most that I've really dove into, well, layers specifically, is doing things like when you want to animate the background color of a view, it's easy because you can just say my view dot background color goes whatever. But if you want to get into the corner radius, or the border width, or border color, or anything, you need to dive into the views layer, right? And then that's where you can start accessing those properties. And so diving into that, and things like CoreAnimation's own slightly more, at least to me, complex animations, like CA basic animations, and that's the only one that I can think of off the top of my head, are a little bit more work, but I'd assume that all of the UIView.animate are using CoreAnimation behind the scenes, and of course I'm also sure that CoreAnimation is the thing that's driving all of the animations that we see in iOS in general.
Yeah. And so let's go into how CoreAnimation works a tiny bit, so that way we can get a good idea of what's going on here. And it all starts with a root layer that has it contains everything else basically, and every other layer will be a child or sub-layer of that root layer in some way. And this root layer is what represents your app as a whole. And that layer is often passed, in iOS's case, to Springboard to be rendered. Like you're not actually rendering your layer contents. The operating system's uh, like parent process for the Windows server is what's rendering it. And macOS actually went through a similar change like about a year or 2 years ago, where prior to that, like in the very early days, it was your view that was rendering a layer, and then later it became your window that was rendering a layer, and then later after that, it became the Windows server that's rendering your layers. And what this means is that more and more of the rendering got pushed out of your app and into the operating system, and therefore it could do more efficient things as a result of that. But these layers really do create a foundational like representation of it. Now, a layer at the end of the day is just a like bitmap. It's an image, and it will render that image according to a frame, basically. And that is at its simplest what a layer is. Now, layers also have a bunch of whimsical controls like background color, corner radius, border, shadows, and all of these are hardware accelerated, meaning that you don't need to like do anything special to animate these properties. The system will take care of figuring out how to transition and render these very effectively without needing to render like a shadow on the CPU and then put it on the GPU. Now, sometimes it needs to do that, but oftentimes it doesn't, which means that you can get a lot of things for free, like corner radius, for instance, where you can just apply it on your layer, and then you'll get a free corner radius. And UI view, which UIKit provides, is just a wrapper on top of a layer. It has a layer as a subproperty, and all of its methods basically route down to the layer to do interesting things. Like if you set the background color on a UI view, instead of needing to figure out how to get a CG color and pass that to the layer, the UI view will just do that for you. It'll take your UI color and translate it. But it doesn't necessarily have all those accessors. So like things like corner radius and stuff are not directly accessible on the UI view. But that's okay because all the accessors that it provides do is call on the layer anyways. So you can just go ahead and say view.layer .corner radius or view.layer.shadow and access those properties directly.
Right. Yeah. So I guess with that, like essentially everything that UI view does is just, I mean, it's just really obfuscating kind of the complexity out of accessing parts of a layer or anything at kind of the core animation level. That's really all we're doing there.
Yeah.
Okay.
And it provides a bunch of helper like methods to kind of bridge the gap that CoreAnimation either provides or does not provide. So, for instance, UI view gives us a great way of drawing views, right? CA layer does not have a robust story there. It just basically says, hey, you can give me contents and I will display them. And that's basically how it displays stuff on screen. It uploads a texture to the GPU and puts it on a rectangle that you provide. But with UIKit, you can go ahead and have a draw rect call that you can go ahead and hook into. It handles events for you. It's going to go ahead and respond to layout accurately. So UI view is doing a lot, but it's all routing down to CoreAnimation under the hood. Much like SwiftUI is routing down to UIKit under the hood. So SwiftUI, you might have seen, like, no matter how many views you have, it does not necessarily correspond to UI views. But at the end of the day, you're still going to have UI views that are going to represent your hosting view, for instance. And then anytime you bring in things like buttons and stuff, you're going to have views for those buttons and stuff like that. So in the end, it's still going to render out UIKit views, which at the end of the day will render out CoreAnimation layers to have things be displayed properly.
Yeah. So I guess talking more about view drawing, we've got, like you mentioned, the wow. Now I just forgot. Is it just draw and rect?
Draw rect. Yeah.
Oh man, it's been a while. Okay, but I mean that would be like, you know, we can. I don't know. I feel like SwiftUI is pretty set up to allow for complex and kind of custom views. There's a lot of kind of manipulation you can do with that, but
Mm-hmm.
kind of before that, drawing just your draw rect method would be kind of the way that we did it. And I think for me, I haven't used it a ton, but one example of when I found it to be quite powerful and kind of I suppose, see what it could be would be we made a clock app in at Atlanta School where it was redrawing the view every second, and that's not hard, right? You have 1,000 milliseconds to draw that. That's not complex. But what was cool was we were doing a fair amount of math and calculation to figure out what was the angle of the second hand and the hour hand and the minute hand, and we were drawing out a completely custom view that without any of that drawing code would just be blank. But then we kind of were drawing using UI Bezier paths and all that stuff to sort of define what the view looked like, instead of using those properties like background color, corner radius, all of that stuff. We
Mm-hmm.
kind of took back that control and said, no, I want to be completely in control of this. And that was one example. We made another example of using UI Bezier paths to draw a company logo, whether it was like the Lambda School logo at the time or whatever it was. You have all of that flexibility if you want to, I suppose, go that far. Now, I suppose that isn't to say that SwiftUI doesn't have that as well. You can do that with paths as well. But draw rect, I think, is really where, if you wanted to do something super custom in UIKit, it was most definitely possible to have something be both look and behave in kind of your own way, using that in
Yeah.
like a custom UI control.
Mm-hmm. And I think the thing to note between like something like SwiftUI and something like UIKit there is SwiftUI is giving you, just like CoreAnimation gives you a few like whimsical properties that are hardware accelerated. SwiftUI is giving you a lot more of these.
Hmm.
And it's giving you so much more of these that you really don't need to drop down to that custom view drawing level
Yeah.
very much even anymore. Even though you still do for like a lot of much more complex cases, but for the simple cases you really don't, which is why SwiftUI feels a lot more freeing than something like UIKit, where it's like,
Hmm.
oh no, I want to have something a slightly off here. I'm gonna need to make
Yeah.
my own UI view subclass. I'm gonna need to figure out how to do draw rect performantly, and all of that. And that is when you start to dig into the weeds, versus just like saying, oh, I'm just going to say dot background circle and then dot clip path and then do whatever you want to do with
Hmm.
SwiftUI. Make a mess of views that are not going to render out into individual views. It's just going to be rendered as one drawing pass,
Right.
which at the end of the day is the same thing, right? So uh, that's like the major difference. And the way UIKit does this is every time you, like, say for your clock example, right, you might have properties for second, minute, hour, and anytime you change those properties, you say second plus equals 1. In the did set for second, you might say, well, view dot or self dot set needs display. And what
Right.
set needs display does is it sets a flag on the view that on the next run loop pass, we want to go ahead and render this. And the reason why we use something like set needs display is so that way, if multiple things change, like the seconds change and then the minute changes and then the hour changes, you're not going to render it 3 times. You're just going to
Right.
end up needing to render it once. So this sets a flag. It's basically just a bool of needs display because you're calling set needs display. And that will go ahead and be set to true. And then on the next run loop pass, the view will go ahead and schedule itself to go ahead and re-render. And it does this by calling drawRect.
Right.
And then drawRect will basically just call your code to go ahead and re-render what it needs to re-render. And then once you do all your drawing code, it will go ahead and collect that into an image and then set that image on the layer that the view owns. And then that layer will go ahead and be updated in CoreAnimation to actually be shown on the screen.
I guess the whole thing with that is you can do like I really like that you mentioned the flexibility with SwiftUI where it's a lot less common that you would have to drop down into doing something like providing your own path for drawing as opposed to in UIKit. There have already been a couple times in my day job where like we have a custom slider and really it's a slider but it looks different, right? Functionally it's a slider, but per our design guidelines, it's not the same, and we had to create an entire UI control subclass and draw everything ourselves. So
It definitely feels less like you're wasting time when you have something that you're going to reuse like that. Like you're going to have that slider all over the
sure,
place, right?
sure,
But then when you have like a one-off, like a profile view that you're not using anywhere else,
mm.
then it feels like super wasteful to make that one like subclass that's just doing that when you could do it very quickly in something like SwiftUI. And I feel like that's where SwiftUI like really shines, is when you have those like very simple one-off things. It
Yeah.
turns out to be just like 5 to 10 lines of code, and it looks perfect, and you didn't even have like a design spec to start with. You're just like fiddling with it as you go, and you're like, yeah, this is
Yes,
what my
this
mind's eye is seeing. And that is how you can get to a very good outcome based on that. And with UIKit, it's unfortunate that you have to do a little bit more, but that's what SwiftUI, the framework, is doing, right? It's writing the UIKit code so that way you don't have to.
yeah. A big thing about that is like laying things out, right? Like you can just put things on the screen on a storyboard, but you also have things like frames and bounds and springs and struts and auto layout and all of these things that kind of are not really a thing in SwiftUI, where we just kind of say, hey, put these things here. Here's a spacer to drop it down to the bottom of the screen, and you're good. There's a lot of different ways of laying things out in UIKit. So, yeah, why don't we walk through them? I suppose.
Yeah, so let's start with my favorite one, which is manual layout.
Okay.
So manual layout is basically taking the concept that you are going to decide where everything goes, and you're going to decide this with math. No. And the wonderful thing about this is it's straightforward, and you understand what's going on, and you can do pretty much anything you want as a result of this. So let's step back a bit and talk about how UIKit positions things on screen. And this all goes down to a view's frame and its bounds. So its frame is its position within its parent's context. So in the context of a UI view, you have a super view, and that super view has its own like position. Say it's the window, okay? It matches the screen. So your view's frame dictates where it is on that screen. Now, if you have a view inside of your view, that view's frame is within your view,
Right.
whatever the context of that is. Now, the bounds represents the coordinate system from within the view. So your view, for instance, it might have a frame with an X and Y of 200 pixels, which means it's 200 pixels to the left and 200 pixels down from the top left corner. But its bounds is going to have an X and Y of 0, because the starting point for any subviews is going to be at the top left portion of your view.
Right.
Now, that doesn't mean that bounds always has a starting point of 0. Like, there are many cases where it doesn't, and we'll get into those a little bit later. But that tends to be how you are going to go ahead and calculate the frames of subviews. You're going to do that based on the bounds of the parent of the super view. And then that basically goes all the way down. So when it comes down to you wanting to position something, all you have to do is calculate the frames of your subviews based on the bounds of the parent view. And if this means like putting 3 views side by side and taking up the whole width of the screen, then you take your super views bounds dot width, you divide that by 3, and that's going to be the width of each of your 3 subviews. And then the first subview is going to be at an X of 0. The second one is going to be at an X of 1/3 of the total bounds. And the second one is going to be at 2/3 of the total bounds. And you position 3 things side by side, and that's as simple as that. If you want to add padding, then you need to start like throwing some math into
Right.
there. So you take that bounds and you subtract 20 on each side, and then you do those further calculations with that, and you push everything by 20. And then that's where most people get afraid of the math, because it's no longer like very simple single operation like calculations that you're doing. It's now multiple operation calculations and multiple steps involved. And worst of all, it gets hard to follow like as you're just looking at it. Like once you write all the code, you might be satisfied that works, and then when you go back to it in 3 months and you look at it, you're like, yeah, I'm not exactly sure why there's like 17 operations here, and it works, but I don't know how to update it. Like, where is the left padding? So if you are doing any manual layout like this, do name your magic numbers. And I mean this in that, like, have constants for a margin that you just declare one line above. It doesn't matter that it's like in a magic place of constants. That's not the point of this. But the point of it is you can go ahead and see that the calculation for that first subview is going to be superview.bounds.width minus margins times 2. So you subtract margins on each side, and that becomes a readable sentence at that point that you can then divide by 3, which that 3 can be number of subviews. And then it doesn't matter if it's 3. It can be 17 if you want, and the math would still work. So that's why you likely want to name your variables a little bit more than you otherwise would if you're doing manual layout, because you can get very lost in the future when you need to deal with it again, right?
Yeah, absolutely. Another thing with that is like, and I've experienced this myself, so this is kind of like a leading question here, but like, okay, let's say that you set those 3 views there, but then you like rotate the screen, and then everything changes, right? Now the width of the screen is now like 1.5 times what it was. What do you do then with manual layout?
Yeah, so that part 1 is positioning things when you create them. Part 2 is actually updating it as things around it change. And the way you do this is with layout subviews. So layout subviews is a method that the system will call, and it's actually where AutoLayout is completely implemented. So if you don't override layout subviews, AutoLayout will do its thing in there and you'll be good. But if you are not using AutoLayout, then this is where you can go ahead and do all the calculations. And oftentimes I will go ahead and say only do the calculations in layout subviews. That way you don't have to have them twice. So you just make all your views, you add them as subviews, and then in layout subviews, that's when you will lay out your subviews, right? And all you have to do is say subview1.bounds equals the mathematical equation that determines exactly where its frame should be. Did I say dot bounds? I meant dot frame. Subview1.frame equals superview.bounds,
Right.
like minus padding divided by 3 or whatever. So if you do it all in there, then everything will react no matter how big the superview gets, because every time the superview changes its bounds, which anytime you change its frame to be smaller, its bounds will also be smaller. It's going to go ahead and tell its subviews, hey, the layout changed, go ahead and lay out your subviews. And therefore it will go ahead and reposition everything. Now, if you don't subclass UI views, you can have view will layout and view did layout on the view controller. And that's another great place to go ahead and do everything for the view controller in there. And the magic with like manual layout is, say, for instance, that the user rotated to landscape. And say that some devices have more landscape than others. So you want to conditionally show stuff on some devices and not on others. Well, you can just have an if statement. You can have an if statement if the bounds.width is bigger than 450. Very arbitrary number, but that's the goal, is you are allowed arbitrary numbers here. You're not like strictly limited to things like size classes, which are endlessly frustrating because it seems like they change all the time and they're not like with respect to actually how much space there is. It's just like a whimsical decision on Apple's part. So this gives you complete control, and you can go ahead and do whatever you want at that point, right?
Yeah, for sure, for sure. Yeah, that was kind of my whole thing, was like the times that I have done a one-off setting of a frame or something, I haven't used those methods like layout subviews or view a layout subviews or whatever, and it's like, oh crap, this only works in one very, very specific sort of parent view frame or bounds, and then it all goes out the window when you try to rotate the screen. I remember that happening very early on in my learning experience. So another one that I honestly I haven't used very much, and I think was perhaps more common earlier, and or maybe if you were doing macOS development, were springs and struts. And I understand sort of the concept of them, and there's kind of a cool animation that you can see when you change the springs and struts in the storyboard of kind of like how the view will interact. But my experience there is really limited.
Yeah, so let's start with why they're called springs and struts, and that's because that little animation used to just be a little spring and a little strut, meaning one part is flexible and one part is not.
Right.
And that was a very easy conceptual way of like determining how the next layout pass is going to change based on the previous one. So back in early macOS days, you had relatively simple layouts. Like you want these buttons to stay on the right side of your window. So as you resize your window, you want the buttons to stay there, right? So you'd do this by saying the right and bottom edges are going to be struts, and the top and left edges are going to be springs. And the width is going to be a strut as well, the width and height. So the button stays the same size because the width and height are struts. It stays in the bottom right because you define those as struts, but then the top and left is completely flexible. And this is a very easy way of like skipping that manual layout pass and not doing the math for something very straightforward. So it's basically always been there, and it's still available today. Especially if all you want is like your subview to be the same size as your super view. Just say it has a flexible width and height and you're done, basically. The downside of this, however, is it's based on the previous position. So as you resize, it takes the old position, applies springs and struts to it as a magical little powder, and then you get your new position out of it. But this gets out of sync like over time. Say you have like a window and you have a button that needs to like grow with the window, but it has a fixed margin on either side, right? So you have a fixed left and right strut, but then the width of the button is a spring. So as you change your window size, the button will change with the window, but it will still be the same distance from the window's edges. Now, you can get to a point where you make the window ever so slightly too small and your button like collapses on itself, right?
Okay.
Now, when it collapses on itself, it might change its margins because it has to. It can't be smaller than 0. So now the right margin or the left margin is going to be sacrificed as you continue dragging your window. Now, as you make your window big again, that sacrifice is going to stay because the new springs and struts calculation is going to be based on that previous position that it just ended up in. And that's where things kind of go out of whack. Now, this happens way less regularly on iOS, where like you don't have free resizing, first of all. But you soon will, as of like iPad OS.
Right.
Though it seems like it's not free resizing. Like there are like fixed positions and things like fade in and out like very awkwardly. Yeah, I don't know what's going on with the stage manager thing. But yeah, it seems like it's going to take some intermediate steps before we get live window resizing technology from the who knows when. Yeah,
From like the 80s.
Well, it's not actually from the 80s. So like the very early user interfaces, I don't know if you remember, but when you resize the window, you're not resizing the window. You're resizing a weirdly outlined shade of the window until you release your mouse. And then it's like, oh, your new window position is right here.
Yes.
Because it couldn't do live resizing. And I think iOS started from essentially the same like opinion. These devices were so slow, no one really trusted them to do live resizing of anything. And when the iPad came out, like that was just the assumption. So when the iPad added like, oh, you can have two apps side by side and you can drag to resize them, it's like the developers probably didn't think of what will happen if there's a live resizing animation between these two states. So we're just gonna fade and that fading has like stuck ever since. So even though the system is likely more than capable of it, thanks to CoreAnimation being super fast, that is not a tested scenario, and therefore it's not something that we have to this day, unfortunately.
Yeah. So with Springs and Struts, then, aside from, like you said, maybe your one example of just basically pinning a view more or less to its super view, is there any reason to use them at all now in UIKit?
I would say not, and that's because AutoLayout, which we can jump into right now,
Yeah.
got quite a few upgrades over the years that make it a lot less crazy to use. And therefore, I would go ahead and say, like, you probably want to just use that, or make some simple helpers if you need to do common cases. That way, you can go ahead and not need to rely on strings and struts anymore, because they do have that one big downside where if things get crazy, then they're going to stay crazy and they're not going to fix themselves. What AutoLayout does really well is it, instead of describing how things should update, it describes exactly where things should be. So it's going back to the mathematical representation, but without as much math. Now, the problem with AutoLayout is to use it well, you do still need to understand what the math is doing, because it is a system of what's the correct term here? It's a bunch of it's a system of linear equations that it's like solving in real time. And you need to like have some conceptual notion of that to use it effectively past like the super basics of it. So the way AutoLayout works is you basically can go ahead and say like, hey, this view, it's going to be 20 points away from my left side and 0 points away from my right side. And if that's all you specify, then by definition, the middle is going to be flexible, right? Then the right side view, that one might say I'm going to be, it's already 0 points away from its left side because you just said that with the other one. But this one has 300 points of a width, and that's all you specify. And then on the right side, you have a third view, and that one is going to be 20 points from the left side one. It's going to match the width of the left side one, and then it's going to be 20 points to the right side. Now, if you specified every single thing in an axis such that there's only one place where things like are undefined, then it can calculate that one place via linear equation. So it can say solve for x being the width of that view, and it will be able to do that. If you specify an x for that view, like in that process, the x becomes the size of your super view, and so on and so forth, because it goes all the way up to the window. If you forget to specify even one of these aspects, AutoLayout breaks down. It has to like make a guess as to what you were trying to do because you didn't provide enough information. So in the very simple case of you want your one subview to be like contained within margins of your parent view, all you need to do is give it a trailing and a leading, or a leading and a trailing, I should say, like constraints, and then the rest it can figure out based on the super view. But if you need to do something complex, you need to make sure that within a single access, you provide enough instructions, but not too many instructions, that it can figure it out exactly, because there's only one solution. Anytime there's more than one solution, that's where the system will say like, hey, you didn't provide enough constraints. Or anytime there's too many solutions, or not enough solutions because it can't solve it, it's going to try breaking a constraint to get there. And you can control how things break by like setting priorities and stuff like that. And then you get into the inequality operators and the content hugging, and then the compression resistance, and all of that. And all of this boils down to just a set of equations that all need to be like managed at once. And if you understand those equations, AutoLayout is like, duh. Like, why don't you see this? But if you don't understand the equations and you can't remember, is content hugging like the bigger equal one, or is it the smaller equal one? And then you're just like completely lost, and none of it makes sense. So I tend to just reach for the manual layout, because at the end of the day, it's the same thing. Like, if you need to understand math for this, might as well just write math. because it's a lot less finicky at that point. But if you want to do simple things, then I would prefer AutoLayout over Springs and Struts, just because it's a little more robust when it comes down to like things falling apart. And you can like one up it. But if you need to do complex things where you're like changing layout drastically based on the size of a parent, then you can probably give up on AutoLayout, because it's not going to provide, like, there are no if statements there. And you can get a little bit crazy with the greater or equal type constraints, but then they tend not to work like you think they work, because of, at the end of the day, needing to, like, it's not a valid constraint unless you have a different one that's like hitting up against it at exactly one point. If there's any ambiguity, then that's where things break down, because by definition there has to be no ambiguity. So yeah, those are my thoughts on AutoLayout. Take that for what it's worth.
No, I think you're right. I think it's most definitely the more complex system for laying out your views. There's power there, but there's also dragons there, so kind of a trade-off. It's definitely the form of laying out views that I have the most experience with out of all the ones we've talked about. Most probably just because of when I came on to iOS development in general. Springs and struts weren't really anything we talked about. Frames and bounds also weren't really, I mean, we talked about them, but not much in the sense of writing entire apps with frames and bounds, because we just used AutoLayout. So I think for me, the thing that helped me sort of understand, like Dimitri said, solving these linear equations is like making, like, every constraint that you add is sort of like a relationship between one view and another, or one view and another thing, right? Whether it's your safe area or another view or whatever. But there's a really good we'll put it in the show notes, but there's a really good online Apple documentation website that talks about, I think it's called The Anatomy of a Constraint, if I remember right, and it goes into like each part of those each part of it, essentially that equation that you make when you make an NS layout constraint, that breaks it down into the multiplier, the constant, the view 1, view 2, what its attribute is, but also it shows like the parts of a view that you can constrain, like the height, the width, the whatever, leading, trailing, top, bottom, not a constraint. Like there's a lot to it. It's by far the most complex system that we've talked about here. And there's a lot of power there, but it's also super hard to kind of get your head around. And to this day, like Dimitri said, the hugging priority and the compression resistance priority, like I have to look those up all the time, because I'll just sit there in the storyboard and say, is it 751 or 749 that I need to do? Because 750 doesn't work or whatever. And there's a lot there. But I think I don't know. Maybe I'm a little biased because it's the one that I've used the most, but that's where out of these I would feel the most comfortable personally. So,
and it's a little unfortunate that like constraints are so heavily reliant on math, because like you said, if you go to the documentation, it shows you the math, and then it's like, aha, like it makes sense. It makes sense that hugging or content resistance and the hugging priority, content hugging and compression resistance. Blah, blah. It makes sense that those are the equations that they are. However, if math does not make sense to you, if you did not do well in geometry class, because at the end of the day, it's not like complex math, but it is. You need to have a robust understanding of like how things work in a visual space with regard to the numbers that like control it. And that's not something that everyone is just trained to do, right? It's something that you need to get used to, and it's something that you need to understand at a fundamental level if you're going to make heads or tails out of this. And it's unfortunate that AutoLayout is like the tool that just thrust upon you an interface builder and is like, oh, pick a number. And it's like, I don't remember which number because like this nicely worded phrase of compression resistance, like it doesn't necessarily have enough information for my brain to figure out how that connects to a number. right? And that's where like Apple could do more. Like they can add that little extra little bit of documentation. Like a lot of those things, if you hover over them, it tells you what it
Yeah.
is. Like they could go ahead and give you that little equation right then and there, and then be that's what I need to like fiddle for. But as well, like the number one like sticking point that beginners have like fallen apart with is whenever they try to use auto layout in storyboards, they have this crazy UI that they set up for themselves, and then the auto layout just does not work for them. And it's like, say you finally do get it to work and you need to add one label. That's when it just completely falls apart yet again, because there's no easy way to really describe this visually. Like, you might be able to say like, oh, like if you remember the fact that across an axis, you need to make sure to have a constraint all the way through, and then vertically you need to have a constraint all the way through. But that gets very hard when you have more complex layouts. And for this reason, like to this day, I basically tell everyone, don't rely on storyboards, because they make things seem easier than they are, and therefore you end up tripping on it a lot more. Like even professionals will just go ahead and like forego this because it's not worth the pain and frustration of needing to like make one change, because you can't see everything that you're changing all at once because it's hidden from you. Like by definition, it's only what you're selected that you're going to see, because it's a lot of visual clutter otherwise. So that's where like describing these in code really helps, and that's why Apple has iterated on how you describe it in code quite a bit. Like at first it started with the ASCII visual language, which was a nice attempt, but again, it's one more thing to like learn, and it's one more thing that the compiler can't help you with until you build and run. So that was a failed attempt. Though it is used when it's describing, like quite successfully, it's when it's describing an error, it will go ahead and use this ASCII language to kind of tell you like how constraints are set up and where things are breaking, and that's as useful as it can be in the console. So that's what it is. So there's that. Then afterwards, you can make constraints yourself with NSLayout constraint, and describe the first view and the second view, the multiplier, the constant. But then you have no visual like correspondation to anything. And then finally, we ended up with anchors, and anchors are great because you can go ahead and say like view1.leading.constraint equal to view2.trailing. And that becomes super clear, because then you have view2.trailing plus the constant is equal to view1.leading. And I mean super clear in that everything is backwards, and people often get the constant like sign flipped because they are like misconstruing how it's put together, because it's not like there's no like rhyme or reason for it to be one way or the other. So it's like whatever your brain thinks of the first time, and then that mistake is forever with you, right? So I say that Apple should take one further step and use like Swift's DSLs to have a like declarative way of describing these constraints based on anchors, but then you can say something very clear like view2.trailing equals view1.leading plus 5, and then it's like it's not ambiguous at all like how all that's put together. And that's something that you could potentially describe with like that DSL and result builders and stuff like this. But for what it's worth, the anchors are not too bad. And if you need to describe a view, you just need to specify at minimum 4 anchors based on its super view, and you're good. If you have multiple views involved, then you have a what's it called? NSLayout constraint.activate with a big array of a bunch of anchors. But at least you can kind of organize that as best as you can, and it's easier to go ahead and insert things when you need to insert them, because you can go ahead and see all the constraints at once because they're all there, they're all declared in one place. Now this whole thing, it gets crazy as mentioned, especially if I want to build a toolbar and I have 17 subviews that I just want next to each other. Well, Apple has a solution for that, and it is called a StackView. And StackViews are awesome because they get rid of most of your need for auto layout, beyond positioning a subview within a superview. That's all you need to care about past that point, because the stack view will go ahead and put things in a stack for you, whether it's vertical or horizontally. And you have a bunch of options that even if you don't understand what they do, you can just flip through them until you find the one that works for you. And that's where stack views really shine, because they remove a lot of that complexity and make it simpler, right?
Yeah, it's pretty close to the way that like V stacks and H stacks work in SwiftUI, where it's just kind of like, hey, I've got the stack view. I'm going to have some subviews in this thing, lay them out for me, and it will try its best to, like Dimitri said, based on like, there's like the distribution, the alignment, I think are kind of the two biggest ways that you can say like, fill this equally, fill it to the point where like, let the views kind of decide more. I think it's more or less let the views decide what kind of like size they want. There are a couple other ones, but that way
There's
all you
overflow
have
behavior if you don't have enough room.
Yeah, you basically just constrain. Let's assume that you're using NS layout constraints. You constrain that stack view to the parent view, and then within the stack view, all of those like 17 subviews for that toolbar, like Dimitri said, the stack view just kind of manages that and says, I'll take care of that, and then you just save yourself 17 times potentially for constraints that you need to make for all of those subviews in the stack view. So super great when sorry, I want to mention real quick, a really cool thing that you can do is you can have stack views and stack views, and that's where it can become a little bit more complex, but also you're very likely saving yourself time and complexity by making NS layout constraints for each of those subviews. So you could very easily more or less do what we do in SwiftUI, where perhaps you have like a V stack or a vertical stack view that basically spans the entire view, the entire window, the entire screen, and then within that have sub stack views that are either horizontal or vertical, and you can basically lay out your entire sort of view controller or page or whatever you want to call it with those subviews. So they can be really powerful once you get used to them. They are a little finicky, like Dimitri said, with the alignment and the distribution and everything, but it's also a very easy and quick thing to change. You could even do it in a storyboard and kind of most probably get those a visual indication of what it would be in the storyboard. So,
yeah, and once again, this is where like SwiftUI one-ups UIKit a little bit, and that, oh hey, you have stack views, sure, but if you want to add those margins, you don't need to like do anything with constraints. You just add a padding. And you're done with the margins. And then, in your stack view, you want like things to be spaced a little bit differently. And just add some padding or add a spacer, and you're done. And the rest is there. However, and this is the huge asterisk, and like my pain point with SwiftUI, is the stack views in SwiftUI do not have that distribution setting where you can fine tune exactly how things are going to like collapse or whatnot. And UIKit basically like gives you full control to this, whereas SwiftUI makes you like try, okay, what if I fiddle with frames with max widths and stuff like that, and you have to really understand SwiftUI now to like be effective at this, and that's where SwiftUI stack views kind of fall apart, because you have some very basic options with UI stack views that you cannot accomplish with SwiftUI stack views, and that's where like it would have been nice very early on in SwiftUI's history to have something like AutoLayout at the fundamental level. Like you have a fallback. If you want to do something complex, it's possible to do it because you have a system that can describe complexity. Where it seems like in SwiftUI, you didn't have that system to fall back on if you ever needed to rely on complexity. Like at the end of the day, in UIKit, you could always fall back down to math, right? That was always a possibility. With SwiftUI, you had very little view into what the layout system was doing in order to do that. Like you literally couldn't in some cases because the system would either cut you off from one of the directions. Like with Geometry Reader, you basically can read from one direction, but then you lose the ability to surface up from the other. And that's where things fell apart. And the nice thing about SwiftUI 4, whatever version we're calling it, is we now have that layout protocol that can go ahead and allow us to finally describe with rigidity like how things flow in both directions. And that's that missing piece that would have been really nice to have early on, but we didn't have until now, and therefore people came up with tons of hacks, and therefore it became like a joke that SwiftUI is simple until it's not. Like, you can't have two buttons that are equal. And that's just how it is. And although you can get reasonably close, like you just have to decide, okay, I want both of these buttons to equal 200 pixels, and then within that they can be equal just fine. But you can't really have one match the other up to like its optimal size without relying on that magic bit. And that's where like this new SwiftUI layout really comes and helps. But if you ever needed to do that in SwiftUI, you can always use UI view representable and like have two hosting views, and that you have essentially the same thing. So that's where knowing how UIKit works can be to your advantage, right?
Yeah, absolutely. And there are still views that aren't available in SwiftUI. They're kind of escaping me right now. I think they've added quite a few more. Like Progress View, I think, is one that is relatively new. A UI activity indicator just wasn't even a thing.
I think you still can't get the large style, ironically
Oh,
enough.
really? Okay. I know. They do have styles, but it's like either a normal spinner or like a progress bar. So yeah, I mean, like SwiftUI isn't sort of hasn't reached, I guess, feature parity with UIKit in that sense of having the same views. We're still reliant on UIKit for a lot of those things. So there have been in LumaFusion there are times where we've had to use UI view representable or whatever. I always get those confused. But the one that, you pull a UIKit view into SwiftUI, there are times that we've had to do that. So it's definitely a worthy endeavor to, whether it's just to augment your SwiftUI knowledge and skill set, or if you do need to use, UIKit in whatever capacity to learn about these things. And we've got one thing left to talk about, which are ScrollViews, but overall this whole thing, I mean, I don't know if I'd necessarily say like, go study up on springs and struts for a bunch of time, but maybe that's just me, like being the kind of auto layout person that I am and kind of learned that way. But UIKit in general, I think, is definitely something that's still very much a relevant thing.
And that essentially brings us to my favorite view of UIKit, and that is ScrollViews, because it kind of brings all of this together and in an interesting way. So remember earlier when I mentioned that bounds don't always start at 0, 0, and one example of this is a scroll view, because as you scroll, it will literally move its bounds, and by moving its bounds, it will move all the views inside of it, and therefore scroll. And this might seem like a simple concept at first, but what the bounds then represents is a view into the scrolled content that can change over time, if that makes sense. And what this allows is all sorts of interesting scenarios. So, for instance, take table views. Table views are a subclass of scroll views because it's really easy to compose these things in a way that you can go ahead and figure out what the user is looking at. Because you have that content offset that it gives you, and you can basically see, hey, is that content offset bigger than this point, at which point I'm going to recycle this view and put it in a queue to be reused without removing it from the super view. It's still there, I'm just going to move it. And by doing that, you've essentially built a recycling view table view. And collection views do the same thing, and your own views can go ahead and do the same thing as well. So scroll views give you a lot of robust control over like making things appear in a scrolled way that can otherwise be complex, especially if they don't fit well within the existing notion of like a collection view or a table view, and you want to do something a little bit different. This can be stacked with like zooming, and guess what zooming does? It scales the bounds disrespective of the frame. So now instead of 1 point in bounds representing 1 point in the frame, 1 point in the bounds represents 2 points in the frame, meaning everything is bigger. And it can be rendered appropriately because your subviews, they just think that they're bigger as a result of this, or smaller. Like the direction always confuses me because I am 100% horribly dyslexic. But that is something you can just try both and see which one works, and you can get past that quite easily every single time. But yeah, scroll views are great because they really encapsulate how UIKit works at a fundamental level. And if you want to feel confident with UIKit, like if you can feel confident with custom scroll views, then I think you've mastered UIKit to a certain extent. In terms of the layout and the views, not in terms of like all the view controllers they can potentially use. That's a completely separate can of worms that we'll not get into today. But scroll views, they work with AutoLayout just fine. Like you can constrain the inside of the scroll view just as you can constrain the outside of the scroll view, and it will do what you think it will do. It will make the inside scrollable. So that's all been hooked up on your behalf already. You just need to go ahead and set things up. So you can do it manually, you can do it completely custom. That's up to you.
Yeah. It's funny that you mentioned like that's when you feel like you've mastered UIKit, because scroll views always have given me like the hardest time, and it's been a long time since I've used them. But like you're saying, like you need to, constrain the outside of the scroll view, and you constrain the inside of the scroll view with the contents of the scroll view. That was always like something that I can never get past. So I've got a little bit of work with UIKit still to go. It sounds like, because it was hard to get things to scroll, and I feel like last time I did it, which was years ago at this point, but I just kind of had to throw constraints at the wall until some stuck and scrolled the way that I wanted them to. So
yeah, and scroll views are still one of those places where the SwiftUI version leaves a little bit to be desired. Like you don't get any updates as far as like what the current scroll position is until you need to go ahead and like stick a geometry reader, and then you lose all layout. So that's like one of my first things that I will go ahead and make a UI view representable for, like tailored to what I need it to do. But it's just basically going to wrap a UI hosting view and just like pass that through. And I would say that is the easiest way to go ahead and hook things up to your advantage, because you can use all the power of a UI scroll view from SwiftUI. You just need to go ahead and choose how you want to hook it up and which parts you're interested in. Because the SwiftUI one basically says, hey, is this horizontally scrolling or vertically scrolling? And the rest is up to you. And you basically get no indication when like things are sticky and stuff like that. So all of that is entirely up to you to do custom. So you can go ahead and get a lot of that for free just by wrapping a UI scroll view and surfacing the pieces that you really want to SwiftUI. This week's episode of Code Completion is brought to you by Sticky Widgets. Sticky Widgets is the absolute easiest way to put a sticky note on your home screen and edit it quickly. It's so easy, you never need to open the app itself. Add a sticky widget to your home screen through the iOS home screen editor and tap on it to edit. That's about it. Of course, there's tons of customization options as well: font, color, text size, alignment, all conveniently located in the system's edit widget interface. Add as many sticky widgets as you like, or put them in a smart stack. Sticky widgets are digital sticky notes for your phone. Use them however you'd like. Sticky Widgets is a free download on the iOS App Store, and additional font and color options are available for a one-time in-app purchase. Thank you so much to Sticky Widgets for sponsoring Code Completion. Check out Sticky Widgets on the iOS App Store today. And widgets are an example of a place you cannot use UIKit at all. Because it's entirely SwiftUI. So it seems more and more that you just kind of need to learn both. And even if you want to like be 100% SwiftUI, you still need UIKit to make your app like 100% an app. And that's the unfortunate truth. So just like learning the math can help simplify how AutoLayout works, learning UIKit can help simplify how SwiftUI works, and can make it a little bit easier to do things that you're trying to do without like some really crazy hacks of like trying to mess with geometry readers and preference anchors, and all those things
Yeah.
are not documented. Yeah. Now, in my never-ending quest to HomeKitify my home, we recently got an ecobee thermostat, which I ripped off
Nice.
my wall to show you. So this is a black puck. You can see through it. And it just plugs into your wall once you do all the wiring. And it's really neat because it is something that I can tell Siri to turn on the thermostat without needing to get up and go over to it and turn it on. But also, it's really neat because it will go ahead and, if you set it to auto, like do things efficiently as much as it can, like take humidity into account when it's like deciding which temperature to cool down to. It has sensors that you can test other rooms. It's not just the thermostat that's like testing the air. It can go ahead and notice that the living room is significantly hotter and that needs to be cooled down for you to be comfortable, and stuff like that. So one really cool thing is it will go ahead and like hook into your local like electricity provider and see if there are any rebates and just sign you up for a rebate, which makes the device instantly cheaper. So if the price was something that was scaring you, that is a way around it. And it's not owned by Google or Amazon or any of these companies
Yeah.
that like to harvest tons of data for who knows what reasons. So if you want to kind of have a non-invasive device, and we can maybe talk about some of that more later, then this is a great device to have in your home.
Nice. I have the, I would assume, older and littler brother of what you have. I have like the Light 3 version of the
Mm-hmm.
ecobee. So it's great. That was uh, about the very first modification to my home that I did when I got my home, was rip out the dumb thermostat and put that one in, and it's worked great ever since then. I love just, yeah, like you said, using it from HomeKit and not having it be tracked by any of those big companies. But like, it's so nice when I'm just like I'll take so my the bathroom in the master bath or master bedroom, yeah, master bathroom, whatever, doesn't have a door. It's just connected to my bedroom, right? And so it gets drafty when I take a shower, so I just turn the thermostat off from my phone so I don't get like cold air coming in through my shower and everything when I'm taking a shower. And you don't have to run downstairs to do that in a towel or whatever. It's just right there. So definitely recommend getting a HomeKit thermostat. It's great.
Yeah, and you can one up that by getting one of those Chingping like air quality
Mm.
monitors. And if the humidity goes up, you can have that trigger your thermostat to go ahead and turn off the air, for instance,
Oh,
and
don't
then
do
you can
that to me.
automate that whole process. And that's the dream of HomeKit devices. A little AC in my office. I have some grievances I can share about that in a
Mm.
little bit. But yeah, that's something that a full thermostat can go ahead and do, and that's quite nice. I've also heard that the ecobee thermostats can connect up to smart vents, which are a
Oh,
thing
cool.
that can automatically open and close in individual rooms, so that way the
Hmm.
thermostat can go ahead and pump air into one room instead of all seven, or can shift like, hey, this room is getting cold, I'll set this one to 50%, this one to 100%. I mostly like wishfully thinking it can do all those things, but I
Uh-huh.
imagine like the technology is there at this point to be able to do that. So I have not like ventured down that route quite yet, because
Hmm.
all the little panels are like slightly somewhere like cut, like none of them are one shape. So I don't know if I'm gonna go ahead and like do that. And equally, I don't like putting batteries in things. Like if some, I would like something to be wired and
Hmm.
not need to think about changing batteries. Door locks are like enough for that. So yeah, not sure I want to go ahead and get vents that need batteries that need changing. Because like, oh, the vent needs changing again.
Yeah.
And then that's just like
That's
a pain of maintenance. But
yeah, that's the hindsight of already having the house, and you're not like building a house to be like, "Oh yes, let me put wiring through my air conditioning vents and everything." Like
mhm.
that'd be great, but the house is already built, so you're like, oh, that'd be a pain. Like if I,
Yeah,
if I
that's when you
were to
have
build,
multi zones like from the beginning, and then you have that
Mhm.
one big HVAC, but then it's just going into different ducts that all have panels
Yeah,
already.
yeah. I mean, if I were, knew what I knew now, I would have ran like, weatherproof Cat 6A, in corners of my house, so I could put PoE cameras all over my house, and it's like I, I'm not gonna put a battery powered camera on the side of my house that I have to go get up on a ladder every 6 months to replace and everything. So yeah,
Yeah, I'm
hindsight.
like this close to getting those, those door things that like automatically close doors in offices.
Yeah.
I'm so close to installing them on my doors because then I can run basically a wire from my stupid door lock to that, have it like go through the mechanism, and then out on the other end, and have it be plugged into some DC power source that just supplies, I don't know, what is it, 6 volts of like DC current to like the four like 1.5 volt batteries that would be there,
Oh, okay.
and then just not need to think about battery power ever
That's
again.
awesome.
But it's like way more involvement than it needs to be, and my
I
door is like
know.
falling apart anyways. So I'm like, I'm just gonna wait.
Yeah.
I am like slightly glued to the idea that I can get a nice door with like glass windows that have that like LCD
Oh,
frost
so
on it.
cool.
You know what I'm talking about, right? The
Yeah, yeah.
ones where it's like with a flip of an electric current, it's
Uh-huh.
transparent or opaque.
Yeah. Yeah, the
And my
crystal's
my
like a line.
dream, yeah, and my dream is to just be there on Halloween, and when people say trick or treat, I just like flip the thing. It's like that'd
That's
be
awesome.
perfect.
Best
Um,
use.
yeah, scare every delivery person possible. It's like, who's there? Clink.
That's
So
awesome.
yeah, for that I would need electric current anyway. So at that point, I would think about just wiring all
Hmm.
that crazy stuff up. But yeah, that's a different kind of problem entirely. Um, but yeah, the ecobee has been pretty great. It supports Hey
I know.
Siri. I don't want to say it like as one phrase, but it supports that. I
Yeah.
have not used it. I have enough of those devices around the house that it doesn't need to really do anything. It also supports like proximity sensing, so if people walk in front of it, it can go ahead and turn on lights. I have also not used this because it's like in a hallway that's like 3 doors wide.
Hmm.
That does not need lights to turn on for you walking by, even in like the dead of night. Just like the lights from outside just kind of illuminate just enough. So I have not used those abilities. The one downside I would say is it doesn't give you any control, and I would say this is probably more Apple's problem than Ecobee's problem. But it doesn't give you any control of the fan without AC or heat. So you cannot say like turn on the fan, or turn off the
Um,
fan. You have to go ahead and set up a shortcut that will go ahead and like set up and configure it in some special way. So that was one issue. But that's easily solved by setting up shortcuts for everyone in the house. So that way, if they ask, it goes through their phone, and if you ask, it goes through yours. Um, so yeah, that was our way around that. But yeah, otherwise, quite happy.
yeah. Yeah, you'll I don't know if you've got it recently, but like it'll also, I think it's maybe every season or so, it'll tell you like how much energy you save by, using it because it's smart or whatever. But also like the percentage of like you're in the top X percent because of, your energy usage. And it's always fun to like see mine be like in the top 10% of like least energy usage in the winter because my house is cold, and then like being like the bottom 90% in the summer because I keep my house cold and my AC's running a lot and I feel bad about it, but I I get sweaty and it's gross. So my AC is on a lot, and I have a second air conditioner just in this room, a portable one in my office when I'm working. So, but you kind of get cool insights like that. So it's been I think overall a good thing. Yeah.
Yeah, you have to get a mini split. And those they are like
Yeah.
this room is so nice ever since we got one. Grievances aside,
Hmm.
um,
Well,
So like,
maybe I'll wait until like you somehow get through to them. I know they don't have a presence on Twitter. They add HomeKit support, and then I'll get it. And I'll
yeah.
just benefit off of your hard work, like I
No,
always do.
thank you. Yep. Uh, so yeah, with all that out of the way, I want to personally thank everyone for listening in this week. Please be sure to follow us on Twitter at Code Completion to know when new episodes go live, and feel free to tweet at us if there's ever a topic you'd like for us to dig into. Most importantly, as a small podcast, please be sure to share this with your friends and family who are also interested in any part of the app development process. It's your support that enables us to continue doing this, and we want to grow a healthy community around everything we discuss. Once again, I want to give my thanks to Spencer, who's at Spencer C. Curtis. That's SpencerCurtis on Twitter, for joining me this week. My name, once again, is Dimitri. You can find me at Dimitri Buñol. That's Dimitri Bounil. And we'll see you all next week.
Bye.
Bye. So yeah, grievance time.
Hit me with your grievances.
Okay,
Because
grievance
obviously
time.
the company won't listen because they're not on Twitter.
So definitely no HomeKit support.
Dang.
They did not even respond to me via email, so that's a thing. Second grievance time. I found out if you just leave the AC mode on, it will do what you expect it to do. It will kind of lower the temperature until it reaches its threshold, and then it will turn off the compressor. The fan will still kind of circulate air, and then as the temperature goes back up, it will turn the compressor back on, and then it will just like continue that process. Now, I found out via the little Chingping like monitors that every time this was happening, there was a spike in humidity. Like up until like 65, 68, 70%, which is very humid. And I noticed this like the only reason why I thought of this is because I went into the room at night and it was like damp and like sticky and hard to breathe, and I'm like,
Yeah.
something is off here. So I found out that whenever it needs to start like whenever the compressor goes off and the fan continues, it's somehow blowing the water it collected that's
Right.
still draining back into the room, because all the air is like flowing right on top of it, and it's acting like a humidifier, and a very effective one because it's a small room, and apparently it's like enough water that it pulled out to
Totally.
fill the room with like tons of humidity. So like I start panicking because it's like a very damp, humid room full of electronics. I'm like, I am not happy with this situation. So my first like instinct is maybe it's not draining on the outside.
Yeah.
And then I did eventually realize it does drain fine. Like end up with like a half a bucket per day, so it's doing its job, pulling humidity out of the air, and it is collecting outside. The next thing we thought of is maybe the unit is like not like angled perfectly to like evacuate the water, and it seems like it is, because we like put it to level, we disconnect and like did this so that way it like potentially goes towards the hose. We tried pouring water into it. Everything seems to work fine. So whatever it is in there that's like collecting the water, that's just the way it is, and it seems to be working as designed. So the last thing that this made us realize was the unit did not come with filters that it says to change every 2 weeks. And that was confusing because I was like, oh, there are filters on top, and like there's like a screen at the top of it. That turns out that's not the filter. There are like 2 filters that you should be able to like just put in. They just don't exist. So that's a thing that we'll need to probably pay $8 for to get eventually. And yeah, that's like the start of the end of the grievance part. The thankful part is, since this is a smart thing with HomeKit support, even though there's no HomeKit support, it turns out that you can automate some things. Now, the parts that you can automate, you have to understand a little bit of Chinese, because out of nowhere, some of the properties that you can like do something based off of are in Chinese, and that's just a fact of life. So as you make your little automation, you need to kind of navigate through that. And I think my years of like Japanese study and my 1.5 years of Chinese study that can help me like navigate that just enough to know what the hell I'm doing. And I was able to set up an automation that when it like goes above 80 degrees Fahrenheit, it will turn on the AC, and it will set the internal temperature to like Celsius, because apparently when you set the temperature, it has to be in Celsius, which is, I don't know.
Cool.
Why. So I had to do some calculations to get it to like 72 Fahrenheit, whatever that corresponds to in Celsius. And then when it drops below that temperature, I have it like automated to just turn off.
Yeah.
And for the most part, this works. Like the humidity problem is completely gone, and the room like is as I need it. And I have a separate little what are these called? Vornado fans, the little circular ones that like act more as a air bazooka than a circular fan. Like it just makes a column of air, which is very effective for like moving air around. And that just like circulates the air internally, and does a pretty good job of that. So yeah, that seems to work.
So those fans, I guess, if the fan on the air conditioner isn't on, then it doesn't circulate that humidity. It just
because there's no humidity to like capture, right?
Right. So you're just using those other fans so that the air conditioner doesn't have to run, and then give back all that humidity to the room.
Exactly.
Okay. Interesting workaround. I mean, it works, but kind of a little bit of a pain, I guess.
So there's one hang up on that, and you'll notice it the moment I forget to do it. If I don't turn off the automation, it goes beep, 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 beep every time it turns on. And then it goes beep, beep every time it turns off. And I'm like, why?
That's super, like, I mean, my garage door will do that because it's like, I guess a person could get crushed under the garage door. But like,
the little flap is going to crush you.
Yeah. That's interesting.
So it's not like a disturbance elsewhere in the house, and I only noticed it like yesterday, so like I remembered to turn it off before we started recording. But yeah, I may forget in the distant future, so sorry about that in advance.
Excuse me. No, it's all good. That's interesting. That would be the point where I'm like, I wonder if I could just take a soldering iron and just like undo that small little, well, I don't know. I guess when you probably have a remote or whatever and turn it on, it makes a sound as well. That would annoy me though.
Yeah, and you kind of need it with the remote because the remote is one of those like dumb IR remotes that
you don't know if it actually.
Yeah, you don't know if it actually connected or not. So I don't know. The remote seems to have like a mute button. I think the mute button is to like make the fan really quiet, though. It's not necessarily for the beeps. So
maybe in the app they have something. I don't know. That seems weird.
It requires some investigation. Thankfully, the app seems reasonably well written. Just like mislocalized in some capacity, which is just life.
It's like a Pioneer brand, right?
Yeah.
I mean, it's not like a completely random brand. My stereo in my car is Pioneer, so there's that.
It's a different Pioneer, I think.
Oh, is it? Do you think?
Yeah.
Oh.
Wow. So, yeah, it's his life.
It's his life. Well, so I guess the follow-up question from this saga that we've been through for at least a week. I don't know. I can't remember. It's been a while. Are you gonna? Oh no, you sent an email to them and they didn't respond. So there's
no response.
No strongly worded email even made a difference.
No, and that one wasn't even strongly written. That was please help. No response.
No, dude.
So yeah, it's his life. The unit works though, so I'm aside from the part where it like pumps humidity into the room. But
except when it doesn't, it works.
Which that workaround has a slight problem of beep. So I will continue the saga until it's complete. Trying not to bring out the soldering iron because that involves bringing the unit down, which means I need to disconnect all the pipes that are all like perfectly sealed and shit. So that is not something that I'm going to embark on, I don't think. All I wanted was for this room to be cool no matter what, because it has all the expensive equipment in it. And yeah, it's accomplishing that goal. And for that, I am more or less happy. What I was like, the ideal reason I wanted the HomeKit support was so that way the little temperature monitor can be the thing that controls it going on and off,
Right.
rather than the one that's really high up on the ceiling that has more or less just hot air rather than the ambient room air, because hot air rises and cold air falls. It reminds me of like when I worked in an office. For whatever reason, I sat at the part of the room where all the cool air collected, and therefore I was freezing
And
when everyone
everyone
else
else
was
was
like
fine.
sweating. So like that was the worst.
Yeah.
So the ideal is to have a thermostat where the air collects, so that way that can be circulated properly, or the thing can turn on and off properly. But in this case, the thermostat is way up high, and that's just the way it is. But yeah,
Well, stay tuned for episode. What are we on? 3, 4 of Dimitri's.
at least me installing the AC was also part of this whole
Oh,
process.
okay.
So
All right. All right.
it's a
It'll
long
become a
continued
saga.
saga. Anyways, bye everyone.
Bye.